Alright, so we're using a matrix method in order to solve these two simultaneous linear equations. So the first thing is that they want us to write in the form of AX equal B, where A is the coefficient matrix, X the variable matrix, and B the matrix of constants. So the first matrix is the coefficient matrix. So we can look at the two equations and identify the coefficients. The coefficients are the numbers that are multiplying to the left of the variables. So to the left of X we have 7 for that equation, and for this other equation is 3. To the left of Y we have -2, and to the left of Y we're not seeing a number, but there's actually a 1 there. But we typically don't put 1 because 1 times any quantity is that quantity. So 1 times Y is Y, but we will treat it as a positive 1 that is before Y. So therefore our coefficient matrix, that is matrix A, will include those 4 coefficients: 7, -2, 3, and +1. They're just entries, alright? So these numbers are not connected. They're separate numbers written in a rectangular array. Next, we have the variable matrix X. And so we're looking at the variables that we've been given. We have been given the variables X and Y. And so we're going to utilize those two variables in that matrix X. The next matrix is our matrix B. That's the matrix of constants, or our constant matrix. And in the constants are those numbers after the equal sign. So we have 8 and 9. Plug them in right there. Alright, so that's good. Okay, so now we're going to find the inverse of matrix A. To find the inverse of A, which can be written as this, A inverse, the -1 here means inverse, is equal to 1 over the determinant of A multiplied by the adjoint of A. Now the adjoint of A is actually a matrix. Alright, so let's do that. No, so let's put the 1. The determinant of A can be found by multiplying these two guys. So that's 7 times 1, which is 7, minus the product of these two guys, which is 3 times -2, which is -6. And then we're going to put the adjoint of A. So you see I'll get the determinant, right? This 1 divided by the determinant, which is multiplying 7 times 1, which is 7. Then we subtract 3 times -2, 3 times -2, which is -6. Put a value there. Then we're going to write the adjoint of A, which is actually a matrix itself. And the adjoint of A is found by switching the elements. So we're going to switch these guys, the 7 and the 1. So 1 goes here, 7 goes there. And then the 3 and the -2, we would not switch them, but the signs will change. So from -2 to +2. So the -2 stays in this position, but becomes +2. The 3 stays in this position, but becomes -3. So you have to remember the signs will have to be changed for these guys, but don't switch them. Just change your signs. But these guys we change. We switch them. Yeah. So now simplifying the inverse, subtracting the negative is positive. So this is really 7 plus 6, which is going to be 13. So it's 1 over 13 times 1, 2, -3, and 7. Okay. Next, now we want to solve, right? Remember we had so far the equation was given as AX equal B. That's the matrix equation. Now to solve for X and Y, that's what they're asking us to do here. And X and Y are found in the variable matrix, right? X and Y are part of the variable matrix. You remember when we set it up, we actually have the variable matrix there. So what are we going to do from there? Well, this is what we're going to do. We're going to transpose the A matrix over. So X is equal to, when A goes over, it goes over as A inverse times B. Now remember what the X matrix is. It is the matrix with the variables. And then A inverse we just found is this guy here. So that's going to be 1 over 13. Multiplied by the adjoint matrix. And then the B matrix is the matrix of constants. So we can always go back and check that out. It's the matrix with the 8 and 9 in it, which is right here. This was the variable matrix, by the way, just for emphasis. Okay, so the X matrix consists of the X and Y variable, and the B matrix is the one with 8 and 9. Is it 8 and 9 or 9, 8? Yeah, 8 and 9 right there. Okay, so next, what we could do, I think the best thing to actually do from here is actually to work out, to multiply these two matrices here. All right, now when multiplying two matrices, you want to multiply row by column. Do you remember that? So multiply this row 1, this is row 2. We'll multiply them by this column. So let's start with row 1 by column 1. So now we're going to multiply while we multiply row by column, we actually multiply the first entry by the first entry. So this is what we really have, guys. We have 1 here and a 2 here, then 8 here and a 9 here. What gets multiplied? This multiplies this. So 1 times 8, which is 8, plus, then we're going to multiply this guy by this guy, second by second, 2 times 9, which is 18. Okay, and then we're finished with that row. And so we go down to the next row, right? So we finish row 1. So we're going to go down to row 2 now. So going down to row 2, let's look and see what we have to multiply here. We're multiplying row by column, so we have to remember that. So we're going to multiply first by first. No, it's negative 3 times 18, that's going to be negative 24. Added to second by second, 7 9s, that's going to be 63. And so that's going to be equal to 1 over 13, simplified, that's 26. 63 plus, well, actually, negative 24 plus 63, that's going to be 39. You can always use a calculator for this, negative 24 plus 63. And then we're going to divide each quantity in bracket by the 13. In other words, we're saying 1 over 13 times 26 over 1. 13 goes into itself once, into 26 twice. Right? So we multiply the scalar that we have outside the bracket by each entry in the bracket. So 1/13 of 26 is equal to 2. 1/13 of 39. 13 to 13 goes once, into 39 goes 3 times. And so we have a 3 here. That's the variable matrix X with the components X and Y equals the matrix with components 2 and 3. Now, if two matrices are equal, their corresponding entries are equal. So that means the corresponding entries we have here, X equals 2 and Y equals 3. Hopefully that was clear. Then let's go to the other one now. We have B portion, the B portion. We want to add these two matrices. Now, when you add in two matrices, you add the corresponding entries. So what corresponds to what? The 3 here corresponds to negative 2. And then what else? The negative 1 corresponds to negative 5. You can see that the 5 corresponds to 0 and the 7 corresponds to 8. All right, so we're going to add those. So 3 plus negative 2, all right? So we're going to add 3 plus negative 2. Same thing as saying 3 minus 2, which is 1, right? Then next we're going to have negative 1 plus negative 5. So we're going to add these two guys here. That's going to give us negative 6. When adding two quantities with the same sign, you add and keep the sign. 5 plus 0, that's 5. And 7 plus 8, that's 15. Now let's subtract now. When subtracting, we subtract corresponding entries as well. So it'll be 3 minus 3, that's with 0. Then we're going to have negative 2 minus negative 4. Let's write that down. Negative 2 minus negative 4. This will be positive. This will be positive 2. Again, you can use your calculator for these. Then go to the next one. 5 minus negative 2. That's 5 minus negative 2. Subtracting a negative is positive, so that's going to be equal to 7. Then 3 minus 0. 3 minus 0 is obviously 3. All right, so now the next one. Let's do the next question. All right, so what we're going to do here, we're going to find 1/5. We're going to multiply the term outside, because it's a scalar multiplication. The others we just did were adding and subtracting of matrices. So we added and subtract corresponding entries. But when multiplying a scalar, a number outside by the number inside, you multiply each number inside by the scalar. So we multiply 1/5 by negative 5. 5 and 5 goes once, and that's leave us with negative 1. Okay. In other words, we divide in negative 5 by 5. It will equal to negative 1. Next, we're going to divide negative 5. We're going to divide 5 outside again by 15. That's 15 divided by 5 is 3. Then 10 divided by 5, which is 2. Then 5 divided by 5, which is 1. So each quantity inside gets divided by the scalar. But what we have in the scalar is just a 1 on top. So we divide by just the bottom 5. And we can see why. Again, let's use an example again. 1/5 times 10. Ultimately, 1 times 10 is 10. 5 times 1 is 5. So we're still really dividing 10 by 5, as we can see here. Gives us 2. All right, so that's our solution. Okay, so hope this example was really helpful and will prepare you for your exam.